All right, everybody. So we're going to be doing heat transfer questions. We're actually going to start off with questions number 4. So it says, base the answers to the following questions on the diagram below. The diagram shows a pattern of air movements within a room. Oh, sorry, within a closed room. It says, which type of energy transfer is indicated by the arrows in the diagram? So in our notes, all right, in our notes, we describe convection as a circulation of heat in the atmosphere and fluids due to differences in densities. All right, excuse the spelling typo. All right, etc. So therefore, if I'm in a room and I see the circulation of air movement within a closed room, right, where warm air through the middle, warm air is rising through the middle, and the cooler air is being circulated outwards and sinking. That is an example of convection. All right, that's an example of convection. Anytime you see the circulation pattern of air movements, all right, and we see this similar pattern where we have from the heat source, warm air is rising, cool air is sinking outwards. That deals with convection. All right. All right, number 3. We'll do number 3 very quickly. It says, which statement is best example of heat energy transferred by conduction? So if we look at our notes, we have to remember conduction is when heat moves from one object to another object through direct touch, right? Through direct contact. So therefore, when I'm looking at 3, the only option that shows heat being transferred through direct contact, right, somehow between two different objects, is going to be choice B, right? Heat energy is transferred from the soil to the rocks, all right? This is the only thing that's showing heat energy by contact, right? Heat transfer by contact, which is conduction, right? The transfer of heat between two objects. All right, number 5. So number 5 says, which process, oops, here we go. Which process requires the addition of energy to water? Which process requires the addition of energy to water? There is a page on the reference tables that talks about the process where heat energy has to be added. What page, everybody? That is correct, choice 1. So when I go to the properties of water, I already see I'm looking for only where heat energy is added. And it tells me right here, heat energy is gained through melting, and heat energy is gained through vaporization. So if it's not melting or vaporization, then that means the heat energy is being released. All right. So since I know it's either going to deal with melting or vaporization, then I'm going to go back. Where we at? Here we go. There we go. All right. So which process requires the addition of energy to water? Remember, we said it's either melting or vaporization. I don't see melting here, but I do see vaporization or evaporation, and that is choice C. Number 6, it says, what energy exchange occurs when liquid water at 0 degrees turns to ice at 0 degrees, right? So we know it's going from liquid to solid. And that process, we know that process as freezing, right? We know that process as freezing. So when I look on my reference tables, it tells me during that process to go from liquid to solid, right, which we know is freezing. It tells me right here that during freezing, heat energy is being released. right? Heat energy is being released, meaning that heat energy is being lost, right? So therefore, heat energy that's being lost, when I go back, the option that shows that heat energy is being lost is choice A. So we know during freezing process, the water loses energy, not the air around the water loses energy. We're only focusing on the water. All right, so number 7 says basic answers to the following questions on the diagram below. Which represents 4 stations, A, B, C, and D, in a laboratory investigation in which equal volumes of sand at the same starting temperature were heated by identical light sources. The light sources were the same distance from each station, but at different angles to the surfaces. 2 thermometers were used at each station, one just above the surface and the other just below the surface. The lights were turned on for 30 minutes and then removed for the next 30 minutes. Temperatures recorded each minute for these 60 minutes. So now it says most of the energy from the light sources was transferred to the sand by the process of what? So they're only talking about energy that came from light sources to sand, right? So that means energy that came from the light traveled to sand. Energy that came from the light traveled to sand. Energy that came from the light traveled to sand. Energy that came from the light traveled through sand. Okay? So the fact that it's talking about energy that is being transferred, traveling through space, right, in order to heat up an object is definitely not conduction, right? Because there's no physical contact between two objects, right? We're only talking about the light source and sand, light and sand, right? Transpiration is not talking about transpiration because that includes, oh man, sorry. That includes plants. Okay, so it can't be that. Oh my goodness, sorry. My screen is acting up. I apologize, but we gonna make it. All right. So for sure, it definitely can't be transpiration. It can't be conduction. There isn't a circulation of heat that's being taken place. So there's not convection. So therefore, radiation is the correct answer. And remember, from light to sand, right? From light sources to sand, it's light traveling through space to heat up the sand. That is radiation. All right, number 8. It says basic answers to question 8 and 9 on the graph below, which shows the temperatures recorded when a sample of water was heated at a constant rate from -50 degrees Celsius to 100 degrees Celsius during a 20-minute period. It says the greatest amount of energy, right? The greatest amount of energy is required to heat the sample from point, which point? So it says the greatest amount of energy is required to heat the sample from which point to which point. All right. So the way that we can measure, right, where the greatest amount of energy is required to heat a sample is based on the amount of time that it takes. So first we focus on time, right? And we focus also on the temperature that it's at. But the main thing is time, right? And so the 2 points that is heating up an object for the most amount of time is going to be from choice D to E, right? So from choice D to E is letting me know, since this is the most amount of time that I'm heating up the water sample, it also lets me know it's the greatest amount of energy that is required to heat the sample, right, in order to increase its temperature. All right. So that's something that we have to keep in mind. Anytime that you're seeing where the temperature is staying the same, right, whether it's be at 0 degrees and 100 degrees, this is during the melting process, right? Because once water reaches 0 degrees, now it's a mixture between that solid and liquid. And even here, if you're heating up the object, once you get to 100 degrees, it starts to evaporate once it reaches 100 degrees Celsius, which leads us to number 9. Number 9 says between points D and E, the water was most likely what? Well, not only do I know 100 degrees Celsius evaporation occurs, but we also know through D and E, the greatest amount of energy was required to heat it. And if we look at our reference tables, the greatest amount of energy required to be added occurs during vaporization, right? Where it's 2,260 joules per gram. So that's the reason why for number 9, get back. For number 9, the correct answer is vaporizing. All right, number 10. Number 10 says basic answers to the following question on the diagram below and on your knowledge of earth science. The diagram represents a cutaway view of a flat plate solar collector used to heat water at a New York State location. And then it says identify the energy transfer process by which light travels through space from the sun to the solar collector. So we have light that travels through space, right? From the sun to, let me erase this actually. Let me put it right here, right? If the sun is here, okay, where we have light going directly from the sun to the solar collector, right? If we have any type of energy that is traveling through space, right, in order to heat up, right, in order to heat up an object, right, there's no physical contact taking place. We know that deals with only one process, and we took notes. If you look at your notes, literally word for word, it says it right here. Radiation is energy that comes from a source and travels through space. All right. So the correct answer, especially the fact that it's talking about light that travels through space from the sun, we know that the correct answer is radiation. That is the energy transfer process, radiation. All right. All right, number 11. It says arrows in the diagram below 3 methods of energy transfer labeled A, B, and C. It says which list correctly identifies the energy transfer process A, B, and C. All right, well, let's break it down. Heat is coming through contact at B. If heat is coming through contact at B, that is conduction. All right. If there's a circulation of heat within fluids, like water right here, that circulation of heat is convection. And if there is infrared radiation, right, that is being emitted out from a source that travels through space, that is infrared radiation, right? Oh, let me not say even infrared. It's just radiation, right? Even though we know it is radiation, they just want the energy transfer process. So we know A is convection, B is conduction, C is radiation. The choice that has all that is convection, conduction, radiation is choice B. All right. So that is the end of the video. Make sure to like and subscribe to be alerted for more videos. All right. Other than that, have a wonderful, blessed day, and I will see you guys later. Take care, everybody.